Hi everyone, this is the last video for the solutions to the 2023 HSC Maths Advanced paper. In this video I'll cover questions 23 through to 32. Question 23. A random variable is normally distributed with a mean of 0 and a standard deviation of 1. The table gives the probability that this random variable lies below z for some positive value of z. Probability values given in the table are represented by the shaded area in the following diagram. The weights of adult male koalas form a normal distribution with mean 10.4 and standard deviation 1.15. In a group of 400 adult male koalas, how many would be expected to weigh more than 11.93? So we want the probability that x is greater than 11.93. Now we've been given a table here of z values, so we want to turn this into z, which is normally distributed, mean of 0, and a standard deviation and variance of 1. Okay, so we're going to use this formula. Z is equal to x minus mu divided by sigma, which is, x is 11.93, mu is 10.4, and sigma is 1.15, which on our calculator gives us 11.93 take 10.4 on 1.15, which is 1.33. So basically this probability that x is greater than 11.93 is now going to become the probability that z is greater than 1.33. So that's going to be 1.33. Now you can see we actually want this probability, not this one. So if I look at 1.33, the probability in here is 0.9082. So I'm going to do 1 minus 0.9082, which is 1 take 0.9082, 0, running out of room, 0.918. Can't fit the 8 in, there it is. It's not the answer though, is it? How many would we expect to weigh more than 11.93? So we've got 400 altogether, so I'm going to do 400 times by that probability, which is 36.72. So how many would we expect to weigh more than that amount? Approximately 36 koalas. Question 24a. Gardener wants to build a rectangular garden of area 50 square metres against an existing wall as shown in the diagram. Concrete path of width 1 metre is to be built around the other 3 sides of the garden. Let x and y be the dimensions in metres of the outer rectangle as shown. Part A, show that y is equal to 50 divided by x minus 2 plus 1. Okay, so we want to work out y. We know that this area here is 50 square metres, so that is going to be y take away 1, and this dimension here is going to be x take away 2. So in other words, y take 1 multiplied by x minus 2 must be equal to 50. And we want to turn this around and make y the subject. So y take 1 is equal to 50 divided by x minus 2. Therefore, y is equal to 50 divided by x minus 2 plus 1. Part B, find the value of x such that the area of the concrete path is a minimum. Show that your answer gives a minimum area. Now I reckon a lot of students would have differentiated this and they would have ended up with an impossible equation. We're not asked to minimize y, we're asked to minimize the area of the concrete path, so we actually need an equation for that. So a is going to be equal to y multiplied by 1, and we want 2 of those, so I'm working out all of that, plus this part here, which is x take away 2 times by 1. Okay, so that's 2y plus x minus 2. Now let's substitute this in, which gives us 2 lots of 50, which is 100, over x minus 2 plus 2 lots of 1 plus x minus 2. They cancel out. Right, so we have, let's go up here, a is equal to 100. I'm going to lift that x minus 2 up, plus x. Okay, now we want dA dx. All right, we have a chain rule here, so it's 100 multiplied by -1, our power comes down, x minus 2 to the power of -2, times by the derivative of the inside function, which is 1. And now moving on to here, the derivative of x is 1. Okay, whenever we're maximizing or minimizing, we're going to take our derivative and put it equal to 0. So 0 is equal to, let's tidy this up, -100. Now I'm going to take this x minus 2 to the power of -2 back down to the bottom, plus 1. Okay, taking this over the other side, 100 x minus 2 all squared is equal to 1. Now let's bring that x minus 2 all squared up over here. 100 is equal to x minus 2 all squared. Square root both sides gives us plus or minus 10 is equal to x minus 2. Therefore, x is equal to 2 plus or minus 10, which is going to give us 12 or -8. But x cannot be negative because it's a length. Therefore, x is equal to 12 meters. Now it says, show that your answer gives a minimum area. And so we want to test that, don't we? And so we have to take the second derivative. So d squared a dx squared. Again, we have got a chain rule. So we've got -100 multiplied by, power comes down, x minus 2 to the power of -3 times by the derivative of the inside function, which is 1. And when I differentiate 1, I get 0. Okay, we had x is equal to 12. When x is equal to 12, the second derivative is equal to, well, that is equal to 200 times 12 take 2 is 10 to the power of -3. And you should always work this out. So we have got 200 divided by 1,000, could have done that in my head, is equal to 0.2, which is greater than 0, so it is concave up, therefore it is a minimum. Question 25A. On the first day of November, Jaya deposits $10,000 into a new account which earns 0.4% interest per month, compounded monthly. At the end of the month, after the interest is added, Jaya intends to withdraw $M from the account. Let AN be the amount in dollars in Jaya's account at the end of N months. Part A, show that A2 is equal to 10,000 times 1.004 squared minus M times 1.004, take away M. Okay, let's start with A1. So at the beginning of the month, Jaya deposits $10,000. At the end of the month, that will have received 0.4%, so 1 plus 0.4%. Now that's already monthly, okay, so we don't need to change that. And then Jaya is going to withdraw $M. At the end of month 2, the balance from month 1 is going to get some interest, and then Jaya is going to take another $M out. Now substituting in here, we're going to get, put it in brackets, 10,000, 1.004 take M multiplied by 1.004 take M, and if we just tidy that up, we're going to get the right answer, which is going to be 10,000 times 1.004 squared take M times 1.004 take M. Part B, show that AN is equal to 10,000, take 250m in brackets, multiply by 1.004 to the power of n plus 250m. Okay, so let's try and make a generalized statement for AN based on A2. It's going to be 10,000, following the pattern is going to be 1.004 to the power of n. Take away m lots of 1.004. This is to the power of 1 here, which is 1 less than 2, so this is going to be n minus 1. Take m, 1.004 to the n minus 2. Take away dot, 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 take away m is equal to 10,000. 1.004 to the power of n, take away m. Now I'm going to factorize the m out of all of this, which is going to give me this, plus 1. And now I'm going to turn this part here completely around. Makes it easier for us to sum. 1.004 to the power of n, take m. 1 plus 1.004 plus dot, 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 plus 1.004 to the n minus 1. All right, we're going to use sum of a GP to work out what this is equal to. So remember, our formula is sum of n is equal to a and then r to the power of n minus 1 all over r minus 1. Okay, so here, what have we got? A is equal to 1, r is equal to 1.004, and n is equal to n because there are n terms there. Okay, so we're going to be equal to 10,000, 1.004 to the power of n minus m multiplied by 1, 1.004 to the power of n minus 1, all over 1.004 take away 1. All right, where are we going to go with this? We want to get here. All right, let's keep going. Is equal to 10,000, 1.004 to the power of n, take away m, multiplied by 1.004 to the n minus 1. Now I'm going to do 1 divided by 1.004 take 1 on my calculator as a fraction. Okay, so 1 divided by 1.004 take 1, which is 250. That's nice, isn't it? So this here is equal to 250. All right, we're close. Equals 10,000, 1.004 to the power of n, take away 250m, lots of 1.004 to the power of n, plus 250m. And if I factorize out this here, 1.004 to the power of n, gives me 10,000, take 250m plus 250m, we are done. 25C. Jaya wants to be able to make at least 100 withdrawals. What is the largest value of m that will enable Jaya to do this? All right, so in this case, n is going to be equal to 100. And we want to figure out the value for m, which means that after 100 withdrawals, this whole thing is going to equal 0. Okay, so 10,000, take away 250m, multiplied by 1.004 to the power of 100 plus 250m is equal to 0. And we want to solve for m. So let's expand this first bit. 10,000 times 1.004 to the power of 100 minus 250m times 1.004 to the power of 100 plus 250m is equal to 0. Okay, I'm going to take these two here over the other side. 10,000 times 1.004 to the power of 100 is equal to 250m times 1.004 to the power of 100 minus 250m. And let's factorize this. 250m brackets 1.004 to the power of 100 minus 1. And solving for m, we have 10,000 times 1.04 to the power of 100 divided by 250 brackets 1.004 to the power of 100 minus 1. Now that is equal to 121.527, and I can see that normally that would round to 53. However, if we round up, he won't be able to make 100 withdrawals, he'll only be able to make 99. So the M that we want is $121.52. Question 26a. A camera films the motion of a swing in a park. Let x of t be the horizontal distance in meters from the camera to the seat of the swing in t seconds. Seat is released from rest at a horizontal distance of 11.2 meters from the camera. The rate of change of x can be modelled by this equation. Find an expression for x of t. So we're going to integrate. So x of t will equal, I'm going to bring this negative 1.5 pi out the front because it's a constant. Integral sine 5 pi on 4t dt equals negative 1.5 pi. Okay, the integral of sine is negative cos. Now we've got a reverse chain rule here. So it's negative cos 5 pi on 4t divided by the derivative of the inside function, which is 5 pi on 4, plus c. Let's tidy that up. Equals negative 1.5 pi times 4 over 5 pi, and we've got negative cos, so that can become a plus cos 5 pi on 4t plus c equals, that cancels. I got 1.5 times 4/5, and that's equal to 1.2 cos 5 pi on 4t plus c. Now let's resolve that constant. The seat is released from rest at a horizontal distance of 11.2 meters from the camera. In other words, x of 0 is equal to 11.2. So 11.2 is equal to 1.2 cos 0 plus c. Cos of 0 is 1. So c is equal to 11.2, take 1.2, which is 10. Therefore, x of t is equal to 1.2 cos 5 pi on 4t plus 10. 26b, how many times does the swing reach the closest point to the camera during the first 10 seconds? Now this is what this looks like. It starts up here at 11.2, and we're measuring this distance here, and it goes back and forward, and the closest it gets to the camera is when this thing here is equal to negative 1. In other words, 10 take 1.2, which is 8.8. Now this is to do with period, and the period is equal to 2 pi divided by 5 pi on 4, which is 2 pi times 4 on 5 pi, which is 8 on 5, or 1.6. So it gets through a full cycle in 1.6 seconds. So how many 1.6 seconds are there in 10 seconds? So 10 divided by 1.6, which is equal to, as a calculator, 6.25. So it gets through 6 full cycles, and it won't get all the way back to here a 7th time. So the answer is 6. The swing reaches closest point 6 times. Question 27. The graph of y equals f of x, where f of x is equal to a multiplied by the absolute value of x minus b plus c, passes through the points as shown in the diagram. Find the values of a, b, and c. All right, you can substitute the points in and solve simultaneously. It will take you a bit of time. It's much better to do this question through transformations. What does the graph of y equals the absolute value of x look like? It looks like this. We're obviously upside down, and so a is going to be negative We don't know the value of it yet, just that it's going to be negative. So that gives us this. Then we want to shift it over, and that will be y is equal to, I'm going to change this now back to a, x minus b. And that shifts it over here. Well, we know what b is, it's 6. So b is equal to 6. And then we're going to shift this whole graph up 7, and so c is equal to 7. All right, so we have y is equal to a, x minus 6 plus 7. Right, substitute one of the points in to figure out what a is. So negative 5 is equal to a, absolute value of 3 minus 6 plus 7. So negative 5 is equal to a times 3 minus 6 is negative 3. Absolute value is 3 plus 7. And so 3a is equal to minus 5, take 7 is negative 12. A is equal to negative 4. And there's our three answers. Question 27b. The line y equals mx cuts the graph of y equals f of x in two distinct places. Find all possible values of m. So the line y equals mx goes through the origin. So for example, this line here will cut this graph in two places. And in fact, anywhere up to here, where it just touches, it's going to cut in two places. So let's work out the gradient at that point. We'll just use rise over run, that's 7 over 6. So we want m to be less than, not equal to, 7 over 6. But is that the entire answer? So if we get flatter and flatter and go negative, we're going to be okay and have a solution up until the point where this line is parallel with that one. Can you see that? At that point it's going to miss this line. I've made a hell of a mess here. Let's rub all that out so you can see it. Let's try again. So from here all the way down until it is parallel with this line here. Because at that point it's going to cut this one, that's okay, but it's going to miss this guy here. So what is the gradient of that line? Let's just work that out. So m is going to be negative 5 take 7 on 9 take 6, which is negative 12 over 3, which is negative 4. So we want m to be in between negative 4 and 7 over 6. Question 28. The curve y equals f of x is shown on the diagram. The equation of the tangent to the curve at point T, which is negative 1, 6, is y is equal to x plus 7. At a point R, another tangent parallel to the tangent at T is drawn. So this one will have equation y is equal to x plus something or other, we don't know what. The gradient function of the curve is given by dy dx equals 3x squared minus 6x minus 8 to find the coordinates of R. Now we know the gradient function will give us the gradient of all of the tangents at the point x. And we know the gradient of both these tangents is 1. So we're going to solve 3x squared minus 6x minus 8 is equal to 1. So 3x squared minus 6x minus 9 is equal to 0. Divide everything by 3. X squared minus 2x minus 3 is equal to 0. Factorise. X factors of 3 are 3 and 1. I want the bigger one to be negative, and therefore x is equal to negative 1 or 3, and we knew the negative 1. So R has got x coordinate 3. We still don't know the y though. So I'm going to integrate this to get the curve. Y will be 3x squared, the integral of that is x cubed, minus 6x squared divided 2 minus 8x plus c, which is x cubed minus 3x squared minus 8x plus c. And we know it goes through the point negative 1, 6. 6 is equal to negative 1. Take 3 plus 8 plus c. And so c is equal to 6 plus 1 plus 3 minus 8. What is that? 6, 7, 8, 10. It's 2. So all we have to do is substitute in x is equal to 3 because R lies on the curve. So y will equal 3 cubed. Take 3 times 3 squared, take 8 times 3 plus 2, which is 27, take 27, take 24 plus 2, which is equal to negative 22. And so R has coordinates 3, negative 22. Question 29a. Continuous random variable x has probability density function f of x given by this. Find the mode of x. So that's the most common value. It is going to be the x coordinate that gives you the maximum. Now firstly we'll actually start by making sure that we have the probability density function, because if we have capital F of x, which is the cumulative density function, we're going to do something different. But we do have f of x. Now if I quickly sketch this, I'll show you what's going on here. We've got zeros at 0 and 1, so here and here. We have a negative cubic. Can you see that? The negative x cubed. So it's going to start up here, end down here. It's going to touch here because there's a double root, and then turn around and go through here as a single root. Now, you actually only want the bit that's in between 0 and 1. And we're wanting this point here, which of course we're going to get through calculus, aren't we? We're going to differentiate this. So f of x is equal to 12x squared take 12x cubed. F dashed of x is equal to 24x take 36x squared. And we want to know where that's equal to 0, because that's going to be the maximum point. Let's factorize this. What is it? 12x brackets 2 take 3x. And so either x is equal to 0, and we can see that that actually is the turning point there as well. We don't care. And 2/3. And so that point there is 2/3. That's the mode. (29b), find the cumulative distribution function. So that's where we want to find capital F of x. So recall, it is going to be the integral between 0 and x of, let's expand that out, 12x squared minus 12x cubed dx is equal to 12x cubed on 3, take away 12x to the power of 4 on 4 between 0 and x. Tidying that up gives us 4. 4 into 12 goes 3. Let's rewrite that. 4x cubed minus 3x to the power of 4 between 0 and x, which is 4x cubed minus 3x to the power of 4. 29c, without calculating the median, show that the mode is greater than the median. All right, so we're going to use our cumulative distribution function and substitute in 2/3, which is 4 times 2/3 all cubed. Take 3 times 2/3 to the power of 4, which is 0.59. So this is the probability that x is less than 2/3. Now, the probability that x is less than the median, which we don't know and we're not allowed to calculate, has to be 0.5. So if you've got some sort of probability distribution function here happening, and you've got your median, say here, and this is 0.5, and here you've got 0.59 for the mode, that's 2/3, then the mode must be greater than the median. And you'll probably have to write a sentence to explain that. Question 30a. Let f of x equal e to the negative x sine x. Part A, find the coordinates of the stationary points of f of x for 0 is less than or equal to x is less than or equal to 2 pi. You do not need to check the nature of the stationary points. All right, we have a product rule. We have u is equal to e to the negative x, and v is equal to sine x. And so u dashed will equal negative e to the negative x, and v dashed will equal cos x. So f dashed of x is equal to u v dashed plus v u dashed. Tidy it up. E to the negative x cos x minus e to the negative x sine x. And I'm going to factorize that. All right, we want stationary points. So we want to know when this thing is equal to 0. Now e to the negative x is never equal to 0, so we're going to get stationary points when cos x minus sine x is equal to 0. In other words, when cos x is equal to sine x. Now, you can do this a number of ways. You can divide both sides by cos and turn it into tan x, or you can just think about the graphs. So we're between 0 and 2 pi. Here's sine, here's cos. And we've got 2 times when they are equal. One of them is obviously at 45 degrees, which is pi on 4. And when's the other one? All stations to central. When do sine and cos have the same sign? Here, obviously, that's a pi on 4, and here they're both negative. So that one there is going to be pi plus pi on 4, which is 5 pi on 4. Now, what do we want to know? The coordinates of the stationary points, so we're not quite finished. But it's pretty easy. We're just going to substitute them both back into the curve. So let's start with f of pi on 4, which is equal to e to the negative pi on 4 times sine pi on 4. Now, I'm going to leave e to the negative pi on 4 alone. Sine pi on 4 is 1 on root 2. Actually, I think I'll do root 2 on 2. So we've got 1 point is going to be pi on 4, root 2 onto e to the negative pi on 4. And now let's do the other one. F of, what's the other one? 5 pi on 4 is equal to e to the negative 5 pi on 4 sine 5 pi on 4, which is equal to e to the negative 5 pi on 4. Now, 5 pi on 4 is down here, and that is where sine is negative, so it's going to be times negative root 2 on 2. And so our other point is 5 pi on 4 negative root 2 on 2 e to the negative 5 pi on 4. 30b, without using any further calculus, sketch the graph of y equals f of x for 0 is less than or equal to x is less than or equal to 2 pi, showing stationary points and intercepts. Now we have stationary points, we don't have intercepts. So let's solve 0 is equal to e to the negative x sine x. Now e to the negative x is never equal to 0, so we're really solving sine x is equal to 0. And so x is equal to 0, pi, and 2 pi. All right, let's do something here with the x-axis. We've got pi on 2, pi, 3 pi on 2, and 2 pi. Now I've got a bit of a problem with these y coordinates, which I approximated from the previous question. They're very small. Now we know that this curve is going to go through 0, pi, and 2 pi, and we have a turning point at pi on 4, 0.3. So pi on 4 is there. Let's go up by tenths. So we're going to have a maximum here. Then 5 pi on 4, that's in here, and it's just below the x-axis. All right, let's see if we can draw this. So it comes up, and it turns, and comes down through here. Dreadful graph, sorry. And dips and turns there, and then comes back up through here. And I'd actually label these points. It's pi on 4, I can't remember, it was root 2 on 2, e to the negative pi on 4 from memory. And then here, let's do it there, we've got 5 pi on 4, negative root 2 on 2, e to the negative 5 pi on 4. Question 31a, 4 Year 12 students want to organise a graduation party. All 4 students have the same probability, P of F, of being available next Friday. All 4 students have the same probability, P of S, of being available next Saturday. It is given that P of F is 3/10, P of S given F is 1/3, and P of F given S is 1/8. Kim is one of the 4 students. Is Kim's availability next Friday independent from his availability next Saturday? Justify your answer. And the answer is no, it's not independent. since the probability of f given s is not equal to the probability of f. So remember that if we've got independent events, then this probability here would have been 3/10, because it should make no difference whether he's available on the Saturday or not. So since as these two are not equal, they are not independent. Part B, show that the probability that Kim is available next Saturday is 4/5. So we're going to use these conditional probabilities here. So we want to work out P of S, and we're going to use probability of S given F, which is equal to the probability of S intersection F divided by the probability of F. And we're going to use this to work out this probability here. So P of S intersection F must be equal to P of F times the probability of S given F, which is, what is that, 3/10 times S given F is 1/3, which is 1/10. Okay, now let's use this one. Probability of F given S is equal to the probability of F intersection S over the probability of S, and there's the thing that we want. Let's switch these two around. So P of S is equal to P of F intersection S over the probability of F given S. Now that probability there is the same as this one here. The order's not important. So that's 1/10 divided by the probability of F given S, which is 1/8, which is equal to 8/10, which is equal to 4/5. 31C, what is the probability at least one of the 4 students is not available next Saturday? At least one not available next Saturday. So it's of course going to be equal to 1 minus the probability that they are all available, which is 1 take away. The probability that one is available is 4/5. They all have the same probability, remember, and there's 4 of them, so it's 4/5 times 4/5 times 4/5 times 4/5. And on the calculator, we have, it's equal to 369 on 625, which is approximately equal to 0.59 or 59%. Okay, last question. Now this is also one that I marked last year. Question 32a, the curves y equals e to the negative 2x and y equals e to the negative x minus a quarter intersect at exactly one point, as shown in the diagram. The point of intersection has coordinates ln 2 and a quarter. Do not prove this. Part A, show that the area bounded by the two curves and the y-axis as shaded in the diagram is this. So our area is going to be the curve that's on top, which is e to the negative 2x, take away the curve that's underneath, which is here. Don't forget to put it in brackets. Many students did forget to put it in brackets. That's the major mistake that I found, dx. And we want it between 0 and ln 2. Now that got you the first mark. Now we can tidy this up a bit, between 0 and ln 2. E to the negative 2x minus e to the minus x plus 1/4 dx equals, let's integrate. So we've got a reverse chain rule, e to the negative 2x divided by the derivative of the inside function, which is negative 2, minus e to the negative x divided by the derivative of the inside function, which is negative 1, plus 1/4 x between 0 and ln 2. And let's just tidy that up. We've got negative e to the negative 2x on 2 plus e to the negative x plus x over 4 between 0 and ln 2 equals, now let's substitute ln 2 in, negative e to the negative 2 ln 2 divided by 2 plus e to the negative ln 2 plus ln 2 over 4. Take away, don't discount this 0. E to the 0 is 1. And make sure you put it in brackets because we're going to have two terms here. Negative e to the 0 over 2 plus e to the 0. Plus 0, put that in. Equals, now this guy here. This is negative a half, e, and I've got this negative 2 here. I'm going to go ln 2 and raise that as a power, so that's a third log law. Plus, same sort of method, e, let's take this negative up here as a power, ln 2 to the negative 1, plus ln 2 on 4. Let's tidy this mess up. What have we got here? Plus a half minus 1 equals negative half. Now here, this part here, that's equal to 2 to the negative 2, plus, same here, so that's 2 to the negative 1, plus ln 2 on 4, and that part there is negative a half. Okay, we're getting there. Negative a half times 2 to the negative 2 is a quarter, plus a half, plus ln 2 on 4 minus a half, they cancel, is equal to ln 2 on 4, take away 1/8, as required. 32b, find the values of k such that curves y equals e to the negative 2x and y equals e to the negative x plus k intersect at 2 points. We can see when k is equal to negative a quarter, it intersects at 1 point. All right, let's solve these two simultaneously. E to the negative 2x is equal to e to the negative x plus k, which is e to the negative 2x minus e to the negative x minus k is equal to 0. I'm going to let m equal e to the negative x. That's going to give me m squared minus m minus k is equal to 0. Now for two solutions, we want our discriminant to be greater than 0. So discriminant is b squared, so that's negative 1 all squared, minus 4 times 1 times negative k, which is 1 plus 4k, and we want that to be greater than 0. 4k is greater than negative 1, k is greater than negative a quarter. But is that it? And no, it's not. I mean, it is the last question on the paper and it's worth 3 marks. So what we've done so far just isn't enough. We have a lower limit here, but what's the upper limit? Now, can I say, of the many, many, many papers that I marked, I think there might have been about 3 students who got this fully correct. There weren't many in the state. Now, when we looked at solving this, we only looked at the discriminant, didn't we? The full solution is minus b plus or minus the square root, we already know the discriminant, over 2a. But m is equal to e to the negative x, remember? And this can never be negative. So what I really want to do is solve this. 1 plus or minus the square root of 4k plus 1 all over 2 has to be greater than 0. And I can get rid of that too, can't I? Now, I'm not going to consider 1 plus the square root of 4k plus 1 because that is obviously positive. I'm going to solve 1 minus the square root of 4k plus 1 greater than 0, which is 1 is greater than the square root of 4k plus 1. I'm going to square both sides, and I can because they're both positive. 1 is greater than 4k plus 1. Let's turn that around. 4k plus 1 is less than 1. 4k is less than 0. K has to be less than 0. There's our upper limit. So the full solution is negative a quarter is less than k is less than 0.